first look at how the Saffir-Simpson scale works. Developed by civil engineer Herbert Saffir and meteorologist Robert Simpson, it became an important tool of the U.S. National Hurricane Center in the 1970s. The scale categorizes hurricanes based on the average maximum speeds for their sustained winds. These winds are measured 10 meters above the surface for 1-minute intervals. It's important to recognize, then, that the scale is only based on wind speed, not any other factors. Since each category represents a range of maximum sustained winds, the difference in strength between hurricanes of different categories can be small or considerable, between 1 mile per hour to 45. This means that the scale provides limited information. For example, important factors like rain and storm surges aren't included. The scale did factor in storm surges, which account for most of the loss of life during hurricanes, until 2010, when the National Hurricane Center excluded them due to inaccuracies. They do continue to estimate storm surges using a model called SLOSH, standing for Sea, Lake, and Overland Surges from Hurricanes. However, this has raised the question of whether we need a storm surge scale to give people a better idea of the incoming danger at the hurricane's area of impact. Two scientists from Penn State University, Amanda Walker and David Titley, actually proposed such a scale in 2018, one that could label potential storm surge damage on a scale from 0 to 10. This way, the danger can be more clearly quantified and communicated. The other issue with the scale is that there is no upper limit for a Category 5 hurricane. It's anything with maximum sustained winds of 157 miles per hour and up. This includes a hurricane with sustained winds of, say, 160 miles per hour and one with winds of 250 miles per hour. With the limitations of the Saffir-Simpson scale in mind, do we need to up the ante to a 6th position? Over the last decades, hurricane seasons have gotten worse as rising sea levels and warmer waters increase the frequency and intensity of hurricanes. The 2005 and 2020 Atlantic hurricane seasons broke records in terms of the number and severity of storms. While scientists cannot attribute individual storms to climate change, the effects of warmer waters is demonstrated by 2021's Hurricane Ida, which went from a Category 1 to a Category 4 storm in less than 24 hours due to unusually warm water in the Gulf of Mexico. As the planet continues to warm due to human activities, meteorologists predict that we will see more and stronger hurricanes. And then, with stronger storms come more powerful storm surges and heavier rainfall, leading to costly infrastructure damage and potential loss of life. That said, Category 5 storms are actually somewhat rare, with only 7% of the 243 hurricanes observed since 1983 falling into that category. As a result, the institution of a Cat 6 classification runs the risk of being extraneous. There have, however, been storms that would fit that description. In 2017, the sustained winds of Hurricane Irma peaked at 180 miles per hour. In 2019, Hurricane Dorian's sustained winds reached 185 miles per hour. Such storms are basically Cat 6s in disguise. Hurricane Patricia in 2015 could actually have been labeled a Category 7, should the scale be extended, since it possessed peak sustained winds of 215 miles per hour. Although storms of this size generally tend to weaken once they make landfall, the damage potential of a Category 6 storm is basically limitless. Winds that strong can blow glass out of buildings, uproot trees, and sweep away homes. The floodwaters would be disastrous to both homes and infrastructure, leading to power outages that could potentially cripple the hardest-hit areas for weeks to months. The deadliest Atlantic hurricane on record, the Great Hurricane of 1780, which resulted in 22,000 deaths in the Lesser Antilles, could also fit into a potential 6th category, with 200-mile-per-hour gusts of wind that peeled bark from the trees. Meteorologist Carrie Emanuel of MIT and civil and environmental engineer Ning Lin of Princeton have concluded that such ultra-powerful storms will occur more frequently, thanks to climate change. They distinguish between black swan storms, high-impact storms that are unpredicted, and gray swan storms, storms that are unprecedented but can be predicted, based on climate models. Even though the latter will be outside of our current experience, they can still be foreseen and prepared for. Preparedness is of the utmost importance when it comes to hurricanes, especially if one lives in a commonly affected area. The eastern coast of the United States is particularly susceptible, as are island nations such as Cuba, the Bahamas, and Haiti. Florida in particular serves as an unfortunate bullseye for many storms during the Atlantic hurricane season. So much so that certain counties in the state possess building code laws that require the proper strength to withstand storms reaching a potential Category 5 strength. Yet it's also this foresight to prepare, evacuate, and evade that leads some meteorologists, such as Saffir-Simpson co-developer Robert Simpson, to insist that an increase in the scale isn't the answer. Simpson stated in a 1991 interview that increasing the scale was, quote, immaterial, due to the destructive potential of any storm with winds over 155 miles per hour. Essentially, there's little question as to what you should do if a Category 5 or a Category 6 storm heads your way. Move before it reaches you. Storms with this level of power, according to Simpson, could potentially damage infrastructure to the point where avenues of escape, such as stairwells or elevators, would be inaccessible. There's also human nature to take into account whenever a major storm is announced on the news. Many of us choose to follow local and state authorities when called upon to evacuate in advance of an approaching storm. However, there are also those who choose to hunker down, brace themselves, and ride out even the strongest storm, come what may. These decisions have been seen to occur amid the backdrop of even the deadliest storms, such as 2005's Hurricane Katrina, a Category 5 hurricane that caused $125 billion in damage and 1,392 fatalities. With all this in mind, would adding new higher categories just make people even more likely to ignore the danger of lower category hurricanes? Even a Category 1 hurricane shouldn't be ignored. So what happens when 5 is no longer the highest number? Even Category 1 storms, with sustained wind speeds between 74 to 95 miles per hour, can knock out power for days. If we did add on a Category 6, it could be used to communicate information about those black and gray swan storms. But it would also be important for people to understand that a new category didn't diminish the danger posed by so-called lesser storms. We have arguably already had Category 6 hurricanes in history, devastating, deadly events that have ripped through whole towns, states, and countries. If, or rather when, another one hits, the devastation will be similar to what we've seen before. Storm surges that wash away homes, rainfall that drowns cities, and winds that flip cars and hurl people through the air. Still, humans have proven their resilience time and time again in the face of natural disasters. In the aftermath, we seemingly always find a way to pick ourselves up and rebuild, even in our darkest hours. At the end of the day, preparing for the worst and getting out of the way would serve as the best defense against a Category 6. As it already does for a Category 5, and even for Cats 1, 2, 3, and 4. Hurricanes are nature at its fiercest. To some degree, they're wholly unpredictable, and they always carry a very real threat and danger to life. And although climate change will increase the severity of hurricane seasons to come, how we survive still depends on us, and how well prepared we are to